So you've met the quantum numbers. Now we're going to have a quantum numbers meet electron configuration. And by the time you get to the end, you may start to think that a lot of chemists are a little bit crazy. And that's okay. That's okay to think that. We kind of have this weird obsession with electrons. Where are the electrons and what are they doing? Especially, what are the very outermost electrons doing? So we like to make long lists of where the electrons are. We always start in the low energy side, and we start the list here, and then we increase going right until we get to the high energy side. Now, you already saw this when we were talking about the Aufbau principle, so this would be low energy. The part that's close to the nucleus is like the nucleus is really positive, and it's like holding it really tight, and they can't interact very well because it's so tightly held. But then by the time you get out here, these electrons are like, woohoo, let's just have fun and go crazy, because the nucleus can only see us some of the time, and well, we're just like really active and busy. So that's the outside part. So it's like the beginning of the atom, and the building of the electron starts right by the nucleus, and it goes outwards. So low to high. And then what we do is we use N. Remember, this is the energy. Before, when you were talking about Bohr, it's energy level, but now we have it and we call it the energy shell. So it's still, lowest energy, highest energy. And we still call it 1 to 5 or 6 or 7 or however many you're going to go out. And we group them by energy level. So if we're talking about, let's say, this electron here, I would say, again, N1, it's an S shape. And now this is the one where we don't use the quantum numbers, we just use the shape. I don't know why it's all different, but 1s, and there's 1 electron in there. Now, notice that this says this is the total number of electrons. So if I happen to have 2 electrons in the s orbital, then I would put 1s2 because there are 2 total. Now, if I put another electron in there, it's going to be in the second energy level. So that would be a 2, but notice it's still in the s, and I put 1 electron in there. But if I put another electron in right there, now it has 2 total electrons, 1 and 2. And then on that second energy level, I've got some more places I can put electrons. I can put them over here at the p's, 1, 2, 3, 4, 5. I'm going to put 5 of them on. So it's still the second energy level, but now we're in the p's. And so there's 5. It's how many total there are. So hopefully you're getting a sense for how we do it. So we group it, and we just keep going out, even if our electrons are like way out over there. Now there's a second way that we do it, and it helps us actually see the electrons and how they fill. And it's over here with this orbital notation. And we do the same thing where we take that group, but instead of putting a little 2, we represent the electrons as arrows. They can be full arrows, or they can be half arrows. And so 1 arrow represents 1 electron. Any orbital can only have 2 max. So, for example, in L, the lowest on the left would be 1s, and then we'd be filling 2 s's, and then we'd be filling 2 p's. So again, these 2 electrons, the 1s2, 1, 2, 2s2, 1, 2, and then 5. Now this is where we follow that Hund's rule. 1, 2, 3, 4, 5. So those are the 2 types of notations we use and how we use them. Little note, we are aware this is not the correct picture of the atom. It just helps to understand a little bit of what's going on. Make sure you realize that the s electrons are not in a path. They are like in this big sphere, and then this is a sphere on top of it. And then we have the p electrons that are also sitting in there. But that just takes a while to draw, and it gets a little bit confusing when you're looking at it.